now we're going to look at electron affinity. Now, there is something funny about the electron affinity numbers, and you will see this chart in different ways if you look it up on the periodic chart. Electron affinity is like the opposite of ionization energy. This is the energy to add an electron. So you're making anions. All of these values are listed with negative energy and positive energy. Now, because we are doing this with atoms first, we haven't actually talked about energy and talked about what's going on with energy, except to say that when an electron absorbs energy, that's positive energy, and when it releases energy, it's negative energy. So even though these numbers are large numbers, the fact that it's negative, it means that it's willing to pay someone else $322 to take for someone else to give him their electron. He's willing to pay someone else that much money. Whereas over on this chart, see how these are positive? They are requiring someone else to pay that money just to get them to accept their electrons. So the easiest way to think of this trend is really to just think of these numbers as being absolute value numbers, especially on this side over here. It's easier to think of them like that. If you help, it helps a lot of people to think of it that way. And these are kilojoules per mole. And notice too that I actually marked this off on this column. Notice that the noble gases are really, really like, they don't have high or low values. And that's because they don't have much desire to take an electron from someone because they're full. And these guys, they don't really, they'll take an electron, but you have to pay them to take it. These guys over here, they're just kind of neutral about an electron. They don't really need it. So this trend really should only go to the F position. It is in the same direction, but make a stop around F over in here. Don't make it go all over the noble gases. Noble gases are kind of messing up on this trend. And notice, again, we're going up that direction. You can see it with the charts. So here's a picture. Again, it's the energy to add an electron. So notice that it's on this side. So when you add an electron, it becomes a negative. And again, adding an electron, yours will be corrected here. A negative S, you add another electron, and then that becomes negative 2s. So, like before, there's a funny little spot on the chart. And you'll notice it happens between carbon and nitrogen. Before it was between nitrogen and oxygen, now it's between carbon and nitrogen. So it's whenever it's involving the nitrogen, it's a little funny. So let's look at why there's the exception between carbon and nitrogen. So again, we are adding an electron. Sorry, that was a typo. That's supposed to be negative. We're adding an electron to carbon. So in this case, when we add the electron, this becomes half filled, which is more stable. He wants to give up money for someone to give him an electron. Whereas in this case, you're becoming less stable. He doesn't really care about doing it. He'll take them because eventually he wants to be all the way full, but he doesn't have a strong feeling about it. And so that's why this one happens to be 0. It's like an exception because we're becoming less stable by gaining that electron. So that's electron affinity. If you need to rewatch this video to kind of understand what's going on, you can. Let me do an example of one of the trends though. So if you were to compare magnesium to to oxygen to fluorine, magnesium, again, don't look at the numbers because this is going to confuse you. But don't overly look at the numbers. But magnesium really, really does want to take on some electrons from someone else. I'm saying that. Magnesium wants to lose electrons. He doesn't want to add electrons. And so magnesium is going to make someone else pay it money to take its electrons. So he has a lower electron affinity, and then fluorine has a much higher electron affinity because he's willing to pay someone else for the electron.